Hello class, this is the last video on the revision of basic Year 11 transformations. For 180-degree rotations on the origin, this is simply done by reflecting on both axes. Now, remember how a reflection on the x-axis, we let y equal negative y, and a reflection on the y-axis, we let x be negative x. For a 180-degree rotation on the origin, we just do both. Now, so once again, for this, we're going to factor this where possible. So this becomes negative x squared plus 6x plus 8. So this can become x plus 2, x plus 4. And so now we're going to substitute both y equals minus y and x equals negative x. So this becomes negative y equals negative and plus 4. Once again, just really emphasizing how I'm going to be substituting negative x for where x is. This becomes negative x, and now, just as we did before, we're going to factor out this negative from this first group. Now there's a lot of negatives going on here, so let's take this real slowly. So this negative is from this one, and in this group, I'll actually do this in orange so we can see. Negative x minus 2. There's the times in between again. I'm gonna do this one in purple. And in this group, I'm going to factor out negative x minus 4. Now look at how many negatives there are going to be. It's still negative y, by the way. These two cancel to become positive, so we're left with x minus 2. There's still that negative there, so I'm going to put that negative here in the front. X minus 4. We have one final negative, so this negative y. I'm going to divide that by negative 1 on both sides. So this cancels out these last two pairs to give us y equals x minus 2, x minus 4. Now, if you can think of this visually, it would be this parabola, like so, being rotated 180 degrees, 180 degrees, but on, so in that demonstration that I just showed, its center of rotation is not the origin, but if the origin were the center of rotation, it would look something like so, right? But now to really visualize that, it would become something like this. It would become positive 2, positive 4. And this negative 3 reflected on the y-axis would become positive 3. And at the same time, that 1 reflected on the x-axis would go down to negative 1. So this point would become positive 3, negative 1. So that would be a 180-degree rotation of this parabola. Now, doing this as well, one more time, to this circle, the same thing will apply. We're going to substitute both of these into x and y. So it becomes negative x plus 5 squared plus negative y minus 4 squared equals 9. Now, I'm going to demonstrate to you that factorization without, so in the previous examples, I showed you in gray what can be done in the background, so you can factor in this step, which I'm going to do now. So this would just become x minus 5 squared. This would become y plus 4 squared equals 9. And notice how I've left room just to really demonstrate to you what just happened again. This becomes negative x plus 5 times negative x plus 5. Remember, that's what squared means. There are two groups of this. There's that plus. Likewise again, negative y minus 4 times negative y minus 4. This is all equaling 9. Factoring negative 1 from each of these, I get negative x minus 5 times negative, factored out, x minus 5 plus, once again, same thing for these two, factoring out negative y plus 4 times negative y plus 4 equaling 9. These two negatives cancel to make a positive, and since there are two groups of the same expression, we just write it as squared, and the same logic applies to this one. So that's how we do this algebraically. And now, graphically, rotating this 180 degrees on the origin would look something like this. There's that 180 degree rotation, but obviously we can't just do that. I'm going to cheat a little bit and just draw a circle here. And since we know it's going to be a reflection on the x-axis, it would be here. And then reflect on the y-axis again would go down here. And so marking in all those points, the center of this would be a negation of both of these, so it'd be positive 5, negative 4. And the 4 points surrounding it would also follow the same suit. This point is actually transformed to here, not this one to this one. It's actually this point reflected on the y-axis, and then reflected on the x-axis. That point would be positive 5, negative 2. This point is actually going to be this one. Okay, so this would be positive 5, negative 6. Likewise, this point is actually not this one. It's actually this one here, because look, reflected on the y-axis and reflected on the x-axis. This point is actually positive 2, negative 4. And this point here is this corresponding transformed point. So this becomes positive 8, negative 4. So I hope that gave you an insight into how rotations work, both to functions as well as expressions. Hope to see you in the next video, and best of luck.